ASML makes machines for two main segments. We have logic and we have memory. Both of them belong to the semiconductor industry. So in the case of logic, we have products like CPU and GPU. We only have three big players here. We have Intel, AMD, and NVIDIA. Now please remember, Intel manufactures its own chips, so ASML works with Intel. But in the case of AMD and NVIDIA, it's a fabless business model. They don't manufacture their own chips. So ASML doesn't work with them directly, they work with their partners. Because we already know that AMD and NVIDIA depend on other foundries like, for example, Taiwan Semiconductor. So Taiwan Semiconductor is a big client for ASML. Now, ASML makes many machines and they don't have a monopoly in each segment, but they have a monopoly in one segment, and that's EUV machines. So when it comes to EUV machines, only ASML can do it. They have 100% market share there. And that's why I think ASML is an interesting company. So why do we need these EUV machines? I'm sure you have heard about 7 nanometer, 5 nanometer. So we have heard AMD talking about their next generation chip. Even Intel now is talking about 7 nanometer chip. So when we're talking about 7 nanometer, 5 nanometer, all these small nodes, eventually you will have to use EUV machines. There is no other way around this. So if you want to make these small chips, you will need EUV machines. So that means if AMD is going to succeed, NVIDIA is going to succeed, Intel is going to succeed, they will have to buy these machines from ASML. How is it that a company like ASML gets 100% market share? Because we have already established that these machines are important. So if AMD is going to succeed or NVIDIA is going to succeed, which by the way, we already know they're going to succeed, why is it that other companies haven't started making these machines? ASML is not a small company, so it's not like they're hiding this fact. And second, these machines cost a lot. They cost 150 million euros. So if you can actually make these machines, you won't have competitors, plus you can charge a lot. So why aren't other players doing this? Well, actually, the answer here is pretty simple. Other players have tried. So for example, Nikon is one of their competitors, and they tried developing something similar. Unfortunately, they dropped their plans simply because they thought it was very capital intensive, plus they thought they couldn't achieve decent returns. As a matter of fact, something similar happened with ASML. So when they started developing this technology, I'm talking about EUV, they realized that even they can't fund this. This company always had decent free cash flows, but they couldn't fund the research. It took more than $4 or $5 billion. And that's when they approached other investors. In this case, they approached Intel, Taiwan Semiconductor, and Samsung. They offered them equity, and in exchange, they got some money, and that's how they funded the research process. And now they get to reap the benefits. So now they can sell all these machines, and they have a monopoly here. Okay, so at this point, I'm sure I've grabbed your attention here. But if this company has 100% market share, it's basically a monopoly, plus it has 40 or 50% gross margins, what's stopping other players to enter this market? Because that's a logical question. Well, if you want to make an EUV machine, first you need many parts. It takes more than 100,000 parts. Now, does ASML make each part? Not really. It's basically like assembly. So they depend on other suppliers in this case. But there are 3 or 4 parts that are really critical. And there are only 1 or 2 companies that make this. So for example, if we take a look at lasers, there was only one company in 2013-14 that was Cymer that made these lasers. Well, guess what happened here? ASML acquired that company. So basically, there are 3 or 4 companies that make very critical parts and nobody else can do them. In this case, ASML just started acquiring these companies. So right now, it's a monopoly, but even in future, it's going to remain a monopoly. Because even if you want to start making another machine, you won't be able to because ASML already acquired these companies. So until now, everything seems perfect, but I do need to highlight some risks here. The first one is capacity itself. Right now, ASML is only making 40 machines, 40 to 45 machines. They think this can reach 50 to 55 machines. We are still talking about EUV here. Please remember, EUV is only part of their business. It's only 35%. They think eventually this will be 50 or 55 or maybe even 60%. But right now, it's only 35% because all these other players are still ordering older models. So that's also a big part of their business. So the question here is, why don't they just increase their capacity directly? Why don't they just double the capacity? And there's several reasons behind this. First, as I mentioned, they depend on other suppliers. It takes more than 100,000 parts. You need to assemble everything, you need to test everything, then you need to ship everything. In Boeing, actually they need 3 planes here, then you need to assemble again, test it. It's a very long process. It takes 18 months, sometimes even more than that. Right now they're trying to decrease this time process, but it takes a lot of time. So first, they depend on other players or other suppliers in this case. Second, they can't just increase capacity here because it takes a lot of time to build the factory itself. So if you
ASML is a Dutch multinational company specializing in the development of manufacturing of photolithography systems. Currently, it's the largest supplier of photolithography, primarily for the semiconductor industry. The company manufactures machines for the productions of integrated circuits. Photolithography machines manufactured by ASML are used in the production of computer chips. In these machines, patterns are optically imaged into a silicon wafer that is covered with a film of light-sensitive material, a photoresistor. This procedure is then repeated dozens of times on a single wafer. The photoresistor is then further processed to create an actual electronic circuit on the silicon. The optical imaging that ASML machines deal with is used for a fabrication of nearly all integrated circuits. As of 2010, ASML had 67% of the worldwide sales of lithography machines, with the competition consisting of Ultratech, Canon, and Nikon. The latter two are not able to compete with ASML, as you will see in this presentation. The relentless race to reduce the feature size of electronic circuits and silicon wafers and thus pack more electronics per unit area requires light sources of ever shorter wavelength and the crucial production of the photolithography process which is involved. ASML has developed the extreme ultraviolet light source now in 2021 capable of 5 nanomillimeters or 50 angstrom feature size. The non-obstructed vas deferens of someone who's had a vasectomy has a 40 nanometer size opening, whereas the proximal obstructed side has 300 angstrom. I thought you'd like that detail. Perhaps too much for you to want to know about. They are the only company in the world able to supply these extreme ultraviolet exposure systems and the sole supplier to virtually every major integrated circuits fabricator. ASML corporate headquarters are in Veldhoven, Netherlands. It's also located for research, development, manufacturing, assembly. It has worldwide customer bases with 60 service points in 16 countries. The company is listed on both the American Exchange, NASDAQ, and Stock Exchange. In November of 2020, ASML revealed it had acquired a German optical glass maker, Berliner Glass, in order to meet the increasing needs for its EUV systems. It tends to partner but buys critical elements that only are sole suppliers, and they've been very judicious in their acquisition process. After reporting earnings in July of 2021, the company said it had a near monopoly for machines used by Taiwan Semiconductor Manufacturing, which is the world's leader, 60%, and Samsung Electronics, another 25%. The electronic manufacturers use extreme ultraviolet lithography, UVL, equipment to make silicon chips more powerful with atomic level precision. The daily chart's impressive. I think it's, as you can see, it's well above the 50-day and 200-day moving average and in a continuous trend northward. The earnings have been spectacular. $7.2 billion in 2019 and $9.6 billion in 2020. Market cap is $329 billion. Sales of $19 billion. PE is out of sight at 58.
D sites located in Connecticut, California, and more. Its products are more like airplanes than you might think. In my video about Comac, I mentioned that Boeing and Airbus no longer make the majority of the parts that they put together into planes. Instead, they have evolved into having a system integrator role where they select, procure, and put together the outputs of different suppliers in their network. ASML is the same. Their lithography machines, like those of the twin scan variety, are built out of independent modules, kind of like the Megazord in Power Rangers. 90% of the components that go into these modules are made by the 500 to 600 outside companies within ASML's outsourced supplier network. These are extremely critical companies and differentiate ASML's supplier network from its competitors Canon and Nikon, which tend to do things in-house. 300 of these suppliers are located in the Netherlands. Another 100 are in other parts of Europe, mostly Germany, and the rest are largely in the United States. Coordinating within this global network is critical. Just as TSMC leans heavily on ASML to provide training and advice on how to use their products, ASML in turn leans heavily on its suppliers on how to best use their components. For instance, their strategic alliance with German company Carl Zeiss AG. Zeiss is a specialist in precision optics and helps produce the lens, a very critical part. So why outsource? Isn't that the reason why Boeing can't make good stuff anymore? Isn't outsourcing a scourge of Western capitalism? Well, ASML might from time to time purchase a supplier company to bring critical, unique expertise in-house. For instance, the acquisition of Brion Technologies, a U.S. firm specializing in computational lithography, and Cymer, another U.S. firm specializing in lasers. It happens. But for the most part, ASML wants to remain in a system integrator role and leave as much of the actual manufacturing to its suppliers. There are a few reasons for this. First, ASML can get its module components without needing to learn how to be the best in the world in making that specific part. A single lithography stepper can incorporate over 1,600 individual components. 200 of those are not cheap to procure in times of cost or production time. The company cannot focus on those components' minutiae while at the same time maintaining a big picture view. Second, this allows ASML the flexibility to change and adapt themselves to changing technology trends. If something happens and ASML has to radically change the way it creates its machines, like it will with EUV, then it has the flexibility to make that change without having to deal with the sunk cost of having invested resources to develop a now defunct technology. Third, like with Boeing and Airbus, ASML wants this system integrator role because it puts them at the capstone of the entire massive enterprise, the gateway that listens to the customer requirements and has final say on which part goes where. This role allows for the most economic value. Indeed, ASML is often its supplier's single most important customer. It might represent 50% or more of their revenues, though this is not the preferred situation. Thus, ASML can exercise strong influence on their operations and planning. Many of these suppliers are too specialized to diversify away from ASML. After all, how many customers are out there for high-precision motors or a beam measuring unit? Okay, so now that we have a good idea of what the supplier network is, let us look at how it works. At least, this is how it worked as of the past few years. Might have changed a bit since then. This is the latest information that I have. It starts with the client. Intel, Samsung, or TSMC plans out their future customer and product demand. They need to do this a year or more ahead of time, which can be challenging. They then inform ASML that they would like to purchase a machine to meet this demand and when they would like this machine to be delivered. When making that order, the client chooses from over 30 client-specific options, crafting the end product to meet their own needs. This means that no single machine that ASML puts out is exactly the same as the other. EUV lithography requires a re-engineering of many traditional semiconductor fabbing principles. I've heard it described as revolutionary rather than evolutionary, and I think that's about right. ASML's entire supply chain has to be rejiggered from the bottom up to accommodate these changes. Let me give you one example of this in action. A key challenge for EUV lithography to work is how to make sure that you can etch enough wafers in a given amount of time while avoiding substantial yield defects. But the EUV mirrors have relatively low reflectiveness, less than 70%, so they need a very powerful light source. They achieve this by firing a CO2 laser at droplets of tin in order to create clouds of plasma and ultraviolet light. Why droplets? Because they need to reduce the amount of tin debris from the plasma so to prevent the contamination of the mirrors collecting and focusing the light. At first, they experimented with a rotating cylinder, then they moved to a thin target tape, and then a spray jet, and then a liquid filament before finally settling on tiny droplets. The margin of error when it comes to the power source is really tight, and this has had consequences across the entire supply chain. It is common in older lithography methods to use something called a pellicle, a polymer film just 1 micrometer wide, to prevent particles from casting a shadow discrepancy that gets projected onto the etched wafers and ruins them. In the EUV world, however, even the super thin traditionally used pellicles can absorb and weaken the EUV light. So, while ASML works to develop a suitable pellicle, earlier generations of EUV machines all across the supply chain now have to adhere to ultra-strict cleanliness standards. A particle just 52 nanometers wide, the size of a small virus, can contaminate the EUV supply component. Maintaining such cleanliness pushes the limits of what is technically possible. New proprietary detectors were installed at all supplier premises. Particle flushing steps had to be added throughout the whole build process. Such challenges are why EUV commercialization was delayed for several decades, even after proving the feasibility of the science in the 1980s. Note, it has recently been announced that pellicles are now available for EUV machines, so it is likely from now on that this cleaning won't need to be a part of the workflow. But before that, such cleanliness standards were enforced for several years. Having them now will improve wafer yields and cost. ASML's market leadership in this sector is defined in 2 ways. The first is in the technological superiority of its products. ASML products are twice as expensive as competing products from Nikon or Canon, but perform much better than the competition. They can print in more detail and at a higher rate. That's what the customers want more than price. The second has to do with its very strong record of collaboration. The company works closely with both its customers and its suppliers, conducting between all of them to deliver a product as demanding as any airplane. This track record and constant process improvement helps to keep ASML at the leading edge of the market, and Moore's Law humming along.
All right, time for a mad dash as we get ready for an opening bell as well, just 6 minutes away. What do you got?
Okay, logic and proportion are being thrown out on the ASMLF conference call. ASMLF makes machines that are as big as buses, okay? But you need them for memory chips and for logic chips. And last night, this company guided up. I mean, they were saying, look, we thought that memory demand would be, 20%. Looks like it's going to be 50%. Logic, they thought it was going to be 10%. It's 30%. This is the chip shortage. This is the chip shortage writ large. And it is right in our faces. It's because they just don't have enough of these machines. Everybody misjudged the demand. Speaking of, we talked about Apple. Yes, the demand for devices shocked people. Nobody was ready for the stay-at-home. It seems like nobody's ready for 5G. Nobody's ready for high-performance computing. No one can get any chips. And, David, if you're United States, you're United States, right?
Yes.
Okay, well, there's a picture. Regions where they ship to, David, U.S. is 3%. South Korea, 44. Taiwan, 43. China, 15. David, we are a pitiful, helpless giant, to quote one of my favorite presidents, Richard Nixon.